So if we go over the learning objectives for exam 1, which comprise chapter 1, chapter 2, and chapter 3. So in chapter 1, you want to remember what are the 3 states of matter. It's the solid state, liquid state, and gas state. It's a good idea to visualize what it means in your head, to have an, a picture of, atoms when they are in the solid state, liquid state, and gaseous state. And in the solid state, they would be packed together, but in an orderly fashion, right? You see a pattern, it's organized. In the liquid state, they are also packed together, but it's randomly put together, right? There is no order. And in the gas state, there is a lot of empty space between the particles. Particles are flying around, and they are, quite far from each other. So that's what you want to remember here. Classification of matter. So remember how we classify matter into pure substances or mixtures. Pure substances are either elements or compound. And you recognize an element because it's only made of one kind of atom. For example, aluminum, Al, or copper, Cu, right? If you see only one symbol, it's one element. Be aware that, for example, there is 7 diatomic molecules that are elements, and these are hydrogen here in the upper left corner of the periodic table, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They all make diatomic molecules, which means it's H2, O2, N2, F2, Cl2, Br2, and I2. It's made of 2 atoms of the same kind together, right? And so these, even though they are made of 2 atoms, they are called elements. That's how you find them in nature. A compound, you recognize a compound because you're given a formula with at least 2 different symbols, element symbols. And the formula tells you it's always the same ratio between those atoms, and they will be always bonded the same way. So that tells you it's a pure substance and a compound. And then mixtures, it's when you have pure substances, at least 2 pure substances mixed together. Homogeneous means it looks like one substance. When you look at it, you cannot tell there is more than one substance. But if you're told that there is more than one substance, then you would classify that as an homogeneous mixture. Heterogeneous means you can distinguish the different parts in that mixture. You can definitely tell there is more than one substance. Distinguish the difference between chemical and physical properties and changes. An example of a physical change is when you change a substance from a solid state to a liquid state or a gaseous state, right? Physical change, there is no change in the identity of the substance. Only its appearance can change, but the formula of your substance is still the same before and after the change. And that's the contrary to chemical change. A chemical change is when you are changing your substance into something else. It becomes a different substance with different properties. And basically a chemical change is a chemical reaction, right? So you have to know how to use, count number of sig figs, right? There will be questions with numbers, and you have to count the number of sig figs. There will be, there is that. There is a multiplication division to do, and you need to find the answer with the correct number of sig figs. So remember, for multiplication and division, it's the least number of sig figs, right? When you are doing an addition and subtraction all together, or just addition and subtraction, the rule is different. It's the least number of decimal places. So only decimal places matter, and you keep the least number. And if it's a mixture of operations, you go in order and you apply the rule for each, part of your calculation, accordingly. And so you need to know how to read like a ruler or a graduated cylinder, a volume or length or a mass. Well, masses are easier because typically nowadays they are digital, so you just read all the numbers in the screen. But you need to know how to read a graduated cylinder, for example, and a ruler, right, to the correct level of precision. So always remember to estimate between the lines. You have lines in your ruler, for example, and so you can always estimate one more digit between the two lines, right, where your object falls. Scientific notation, you need to know how to change numbers from scientific notation to decimal notation or vice versa. And so I think most of you get this, but in case you forget, when you have a positive exponent, it's because you have a very large number. A positive exponent means you multiply n times by 10 the decimal part of your number, right? And a negative exponent means you divide n times by 10, the decimal part of your number. So you give negative exponent for small numbers and positive exponents for large numbers. You don't want to remember with left and right. This is a very, very confusing way to remember. Don't learn it this way. Okay, so there will be problems to solve that require unit conversions. So, it's as for example, you have a given amount and you multiply by conversion factors, right? And the conversion factor comes from an equality. And you need to decide how to write your conversion factor by looking at the units. Always have your units written down because they are your guide. That's what tells you what to do next. So you look at the unit in your given amount, and when you multiply by the conversion factor, the denominator should always have the unit of the starting measurement, right? Because you want to cancel units. So, yeah. Density, remember the formula correctly, it's mass over volume. The units, you want to write down the units, and typically it's grams per milliliter or sometimes grams per cubic centimeters. If it's a solid, it's going to be gram per cubic centimeter. If it's a liquid, it's going to be gram per milliliter. But you know that these two units are equivalent, right? Because 1 milliliter equals 1 cubic centimeter. So it's the same unit, but it's just expressed differently. We prefer milliliters for liquids and cubic centimeters for solids. So that's chapter 1. Okay, so chapter 2 involves the periodic table. So know how to recognize the symbol. The number above the symbol is the atomic number, and there is the key here reminding you this. Atomic number above the symbol, element name, and the atomic mass below in atomic mass unit. Yeah, metals are located on the left side of the staircase line, right? All these most of the elements are metals, And then on the right side of the staircase lines, we find the non-metals. The metalloids, there's only a few of them. It's boron, silicon, germanium, arsenic, antimony, tellurium, and astatine, right? Polonium is not metalloid and aluminum is not a metalloid. So atoms are arranged such that they have the same kind of properties per column. And the columns, we call them groups. And, you know the names, by the way. It doesn't say that in there, but, remember that these group 7A are called halogens. 8A are called noble gases. 1A are called alkali metals. And 2A are called alkaline earth metals. So the periodic tables reminds you on how, if your nucleus here is on top here of the periodic table, how electrons are filling the shells and subshells and orbitals. And the periods, which are the row here, periods are showing the filling of the shells. Right, first shell has only 2 electrons, and that's the maximum it can get. Second shell can get 8 electrons. So when we have neon, we have 8 electrons in the second shell plus 2 electrons in the first shell. Third shell, there's the s orbitals on the left, p orbitals on the right, and then the d orbitals. A line below, actually, right? Their energy is higher, so that's why it's a line below, a period below. So you want to remember this general way of filling shells. What is more important is the subatomic particles. Remember what protons are, neutrons and electrons. So protons are the positive, so P, right? Positive are protons, positive charges. Electrons are negative charges, and neutrons are neutral, right? The protons and neutrons are the ones in the nucleus, and the electrons are in the electron cloud around. And the nucleus is a tiny, tiny, tiny dot into a large sphere. The sphere is defined by the electron cloud, the electrons roaming around in there. And the nucleus contains all the mass of the atom. The protons and neutrons, they each have about 1 atomic mass unit. And that's what will give the mass to the atom. Periodic trend, yes. As you go down the periodic table, the size of the atom increases, and this should make sense because you add shells, around the nucleus. But the size decreases when you go from left to right. That's not intuitive, so you need to remember that the size decreases within a shell, within a period. For example, from potassium to krypton, the size of the atom is actually decreasing, right? About ionization energy, what you need to remember is that the ionization energy is larger for smaller atoms. It goes in opposite directions than the size, because it's harder to pluck an electron from a smaller atom than from a larger atom. Okay, isotopes. Isotopes are atoms with different masses for one given element, right? For a given element, you can have different isotopes. And what makes them different is just the mass. But the mass is different because of the number of neutrons. It's not different because of the number of protons. Protons, which are the atomic number here. For example, nitrogen, atomic number 7, has 7 protons. Nitrogen, I don't know how many isotopes it has, but let's say it has 3 isotopes. All the isotopes will have 7 protons. what is different between the isotopes is the number of neutrons. So one may have 7 neutrons, another one 8 neutrons, and yet another one 9 neutrons, right? But they still all have the same number of protons. Otherwise, it would not be nitrogen anymore. And so in nature, you find when you find an element, it's actually a mixture of isotopes, and you can calculate the atomic mass by taking into account the the percentage of each, the percentage of abundance of each isotope and their isotopic mass. There's a formula to follow, right, to calculate this, right? Don't take just a regular average way of doing this. This is not the correct way. Determine the number of valence electrons from any element, and we saw that the number of valence electrons is the group number for all the A group. It doesn't work for the B group, but for all A groups. So for example, group 1A, they have 1 valence electrons. 2A, 2 valence electrons. 4A, 4 valence electrons. 5A, 5 valence electrons. 6A, 7A, 7 valence electrons in 7A. 8A, they have 8 valence electrons except helium. Helium is an exception. It has only 2 electrons in total, and these are its 2 valence electrons. Look at its atomic number. It's atomic number 2. Those 2 electrons occupy the 1s orbital, and that's the filling already the s. That's filling the first shell of atoms already. So remember how helium is an exception. So when you do the electron dot, basically a dot is a valence electron. So for, let's say, for example, chlorine, if you do the electron dot of chlorine, you would, so chlorine is in group 7A, so it has 7 valence electrons. So you would do 7 dots around it. And so the way we do that is, for example, 2 dots above chlorine, 2 dots below chlorine, 2 dots on the left of chlorine, and 1 dot on the right, for example. So that's chapter 2. Chapter 3. Okay, the basic features of ionic and covalent compound. So at the beginning of that chapter, you learned that the difference between ionic and covalent bonds. Ionic bonds are made of metals and non-metals, right? What defines an ionic compound is that it has a metal and non-metals. Typically, it can be more than 1 non-metal, but it's, in this course, we only learn having only 1 metal. And so what happens is that ionic compounds are made of ions. And so the metals are going to be the positive ions, the cations. And the non-metals are going to make the negative ions, the anions. And because positive and negative charges attract each other, so those ions will be attracted to each other and bind, right? It's an electrostatic attraction. And so when you have an ionic bond, what happens is that the metal will donate its electrons to the non-metal, right? It's a transfer of electron from the metal to the non-metal. And so that's for ionic compound, and that's what you learned about ionic compound. Covalent bonds are between non-metals only, or metalloids, but mainly non-metals. So there is no metal in there, right? Covalent bonds are only between non-metals, and they share electrons. It's a different way of dealing with electrons. They share them equally or sometimes not equally, and then you have polar bonds. But for tomorrow, you want to focus on ionic compound only. Use the Yeah, so you can determine the kind of ion you have from the periodic table. And so these are called predictable ions, right? It's a predictable ion if from the position in the periodic table, you can tell what kind of ion it becomes. For example, magnesium here. Magnesium is a metal from group 2A. Okay, you should know that metals make positive ions and they lose electrons, right? To become a positive ion, you need to lose electrons, and it's protons that are not cancelled out by electrons that show up as a positive charge. Magnesium, you know, in group 2A has 2 valence electrons, and it likes to lose those 2 electrons. And so that's why the group number is also the charge on magnesium. And so magnesium will like to become a magnesium 2 plus ion, right? So the charge is the group number for the metals. So 1A, 2A, the B group, it doesn't work for them. And then 3A, right? It's not working also for the 4A or the 5A, right? Only 1A, 2A, and 3A, you can determine the charge of the metal from the position in the periodic table. For the non-metals, you can determine the charge by doing the group number -8. So for example, oxygen in group 6A, you do 6 minus 8 and it's going to be -2. So oxygen, sulfur, selenium, they make -2 ions, right? So non-metals make negative ions. And the reason why all these atoms are doing ions and, you know, gaining or losing electrons, it's because they try to get an octet. It's important to understand that the octet rule, that's what it means. All atoms try to get an octet of valence electrons around them. And to be like a noble gas is the next noble gas or the previous noble gas. For example, fluorine, atomic number 9, but you know, in group 7A here. So has 7 valence electrons, right? 7A here means 7 valence electrons for fluorine. It needs just one more to be surrounded by 8. So fluorine will like to gain an electron and become a F minus ion. And that way it will have 8 electrons around it by gaining one more electron. So that's why, you know, atoms do make ions like that. Okay, and then from 2 ions to find the formula of a compound. So always write the positive ions first, then the negative ion. For example, Mg2 plus F minus, for example. Let's make a compound between these two. So always the first is the positive ion, then the second is the negative ion. And then we learned about this crisscross trick rule that allows you to write the formulas by taking the numbers of the charge of the ion, and that becomes the subscript. So if you have Mg2 plus the 2 from the magnesium will become a subscript for fluorine, and the 1 from the negative charge on the fluorine will become a subscript for magnesium. So the formula will be Mg, and the 1 is implied, F2, right? For example. So the way to find the formula of an ionic compound is to find the set of ions that will make a neutral formula. You want as many positive charges as you have negative charges. But you want the ratio, you know, to be the smallest ratio, right? You don't want a subscript to be more than what is necessary to just have a formula that is neutral. The way we name is by taking the name of the metal first and then the name of the non-metal and changing the end of the non-metal by "-ide". So for example, MgF2, you would take magnesium just as it is written in the periodic table. And then fluorine becomes fluoride. And so it's called magnesium fluoride. And we use the Roman numeral only for variable charge metals. And those are typically the transition metals that are in the B groups, right? Here from scandium to not zinc, to copper here, or yttrium to cadmium. All of these in the B groups are transition metals, and they make variable charge metals. And so for them, you will need the Roman numeral. And remember how the Roman numeral tells the charge on the metal, right? It has nothing to do with the subscript of the formula. It tells the charge on the metal in that compound. Yeah. Remember how zinc and silver are exceptions among the transition metals. Zinc is 2+ ores, so we don't need a Roman numeral for zinc. And silver is always a +1, so we will not use the Roman numeral for zinc and silver. Yeah, so ionic compound typically are what we call salts. And so it's crystalline, very hard solids. So they have high melting point and boiling point. But a lot of them are soluble in water, and they will make aqueous solutions that are conductive, because those ions that make the ionic compound, they dissociate and they become ions that are floating around in water. And because they are charged particles, they will conduct the electricity, right? Electricity is all about having mobile charges that can, move the charges from one electrode to another electrode. So that's how electricity is conducted. Polyatomic ions, yes, it's important that you have this list of polyatomic ions when you are dealing with ionic compound, right? Please have this on hand. I'm not asking you to remember this by heart. So polyatomic ions are made of more than one kind of non-metal. Typically, it's non-metals. And be careful, the charge is written in the upper right corner, and the subscript in the lower right corner belongs to the oxygen. Typically, it's an oxygen. Or for NH4+, it's the hydrogen, right? So the subscript is telling you the number of oxygen that surrounds, for example, phosphorus or sulfur or carbon. Typically, that's what it is. So you should not change that. The subscript should stay, and it's only the charge that disappears when you write the formulas. And we need parentheses around the formula of a polyatomic ion when there is more than one in a formula of a compound. If there is only one, we don't need parentheses. Yeah. So I don't know if this was useful, but if you have questions, please don't hesitate now. Let me pause the recording. Hold on, I need to show that. So the exam will be found on Canvas into a module called exam. Sorry, here. This is my version, so there are things you don't see in your student version. And so you would click here under exam. It's just like a quiz. And here there is a description, and it tells you that it's in 2 parts. The first part, it's 13 questions to be answered on Canvas directly. just like in a quiz. And so a few, maybe two of them will ask you to explain your answer. So because that's the only way for me to verify your understanding. And so there will be questions with explanations, just two, I think. And then the rest of the questions are to be answered on paper by hand, right? I don't want it to be typed, and I would not see the point. It would be difficult. So do them on paper, you know, just have a regular piece of paper, even a notebook with lines, it's fine. And identify the question you are answering, right? You don't need to rewrite the question unless you need that for yourself, you know, because you feel better having it on the paper. So write down your answers. And so it's going to be very important for that, you know, those questions to show as much as possible your work, because I will, you know, give partial credit. It's not just a matter of having the right answer at the end. It's really all about showing your work, actually. This is more important. And so if you use a formula, show the formula you're using, then plug in the values. If you need to rearrange the formula, you do that before you plug in the values. I don't think for tomorrow there is too much formulas, but otherwise for conversion units, for example, write the full calculation and include the units, because they are your guide. It's important to have them correctly written there. When you need to calculate intermediate answers, especially for the atomic mass calculation, I need to see the intermediate answers. If you do not show the intermediate answers, I will not give you some points, so you need to show them. If I tell you to not run the intermediate answers, do not run the intermediate answers. And typically you don't want to run intermediate answers. It's only at the end that we round. Don't forget, sig figs are always something you need to pay attention to, always, when you have numbers, measurements, calculations, and units. So give your final answer with the proper number of sig figs and unit. When you need to answer a question that asks for, you know, explain why, or, you know, why do you think this is so? Please be elaborate. It will be easier, right? Unless you're very good at explaining very succinctly, but don't hesitate to elaborate. And then you will scan those pages and upload them as one file. I'm insisting on the fact that it should be only one file. I don't want to have to open multiple files. This is really taking a lot of my time in clicking and scrolling, and you have to make the effort to put that into one file. So be prepared. So of course you want to have access to Canvas. Be prepared to scan or take pictures of your paper, and hopefully now you all know how to upload the files, right? You should now, because you have done it. Have your scientific calculator ready, the periodic table, the reference packet for Chem 1 Unit 1, right? Which means the tables with the prefixes, the metric to US equalities, the density formula, and then the polyatomic ion list, the flowchart for naming, that can help too. Yeah, that's it for Unit 1. And of course, have some paper ready. And I said 2 hours or so, but you see here, time limit, it's 180 minutes, which is 3 hours. So I hope that will be enough for you to, you know, complete that without being pressured by the time. Okay, so there's only one attempt. So when you open it, be careful to, you know, only submit at the end when you have uploaded your file, right? Yeah, it's up to 50 points. So do you have questions on this or?
I have a question.
Yes.
So you want us to submit it on one file, we take the exam, and then we obviously have to write questions 14, 19 on paper. So we're taking a picture, and then how are we? So,
the 3 hours are for you to do all of this. So the exam will all show up at once. You will have something that will look like a quizzes, right? With questions where you need to answer directly in there. And then the last question, and it's going to show up as question 14. But in there, there will be the text for question 14 to 19. You will have the text. And there, that's where you will have the place where you need to upload the file. So it's within the exam. The last question will have the place where you can upload the file. You understand? Oh.
yeah.
You will open it once and everything will be there. But I advise you to first do the quiz-like part. Then you will reach the questions that are to be answered on paper, and then take a picture and then upload the file inside question 14, where the file upload will be located. Does it make sense? Okay. Yeah, if your internet is not working very well sometimes, or you know, time is really time constraints are a pressure you cannot stand, you communicate with me and I can you know, loosen up things like that, right? I really don't want you to stress too much for this. So if for some of you it's really a problem, let me know. Okay, so I've taken a lot of your time already. So if you have more questions, let me know. Otherwise, as always, I'm available by email. And so tomorrow, if you have an issue, contact me by email, right? I should be available, and unless I'm recording and I may take an hour, half an hour or so to answer, but I should be able to answer emails